In this video, I'm going to continue with the overview of solving equations. Just remind you that in the first two videos, we looked at linear equations. So I'll go through, show you these are the ones we did. The first couple of videos, we went through linear equations, quadratic equations, we looked at rational equations, and today I'm going to continue with part 3. But I need to review a few things. Hopefully you already know this, so I won't go into very much detail because I do have other videos on this. And this is really more like a review of some of the solutions of equations. But just to remind you, let's consider the polynomial p of x equal to x squared minus 4. And I have it factored out for you. It factors in the difference of squares, factors into x minus 2, x plus 2. So then a few notes to keep in mind. Notice that p of 2 is equal to 0. So if I replace the x by 0, whether in this format here or in the factored form, I get 0. So also note that x minus 2 is a factor of the polynomial. Now also note that if I replace the x by negative 2, so instead of putting in a 2 with the x, I put in negative 2, I will also get 0. And x minus a negative 2, which is x plus 2, is a factor. Okay, I'll be discussing here basically comes from theorems from College Algebra, which I won't go into detail and state them, but that's where this comes from. So I have the things like the remainder theorem that you should study in College Algebra, the factor theorem, the rational zeros theorem, among others, be some of the things I'll be talking about here, at least giving you examples of. Also note here that if I take the polynomial x squared minus 4 and divide it by x minus 2, it gives me x plus 2. And that should be clear, right? If I divide this factored form by x minus 2, the factors x minus 2 will cancel and I get x plus 2. Okay? So if I were to divide this out using long division, okay, so just to remind you, if I take x squared x squared plus 0x minus 4. Okay, and divide it. So I'm going to use a regular long division. Divided by x minus 2. So recall that in the procedure for long division of a trinomial or higher divided by a first degree binomial, you always want the dividend in descending powers. So I have x squared, this would be x to the first, and then the constant term minus 4. The exponent on the x is 0. And if there's any missing terms of the variable, you fill it in with a 0, or in this case it would be 0x. The divisor x minus 2 is also in descending powers. So it works like this. X divided into x squared is x. Just like regular division of numbers, and then I multiply the x times the x minus 2. So x times x is x squared. X times minus 2 is minus 2x. And just like when you do, what you do when you divide numbers, at this point we subtract. Okay, so here's a subtraction. So x squared subtract x squared cancels. 0 subtract a minus 2x. The sign changes because of the negative. You're subtracting it, so this becomes a 2x. And here we're subtracting 0 from minus 4, so that still stays minus 4. And then we continue the procedure until the degree of this remainder here is less than the degree of the divisor. This is degree 1. This is degree 1 over here on the x. Okay, so we can keep dividing. X into 2x would give me 2. X's cancel. And then 2 times x minus 2 would give me 2x. And 2 times a negative 2 is a negative 4, minus 4. And at this point, we subtract, everything cancels. 2x subtract 2x cancels, minus 4 subtract minus 4, that becomes a positive, so those cancel. This gives me 0. This is the remainder. Okay, so the remainder in this case is equal to 0. Okay. So notice over here, I have p of 2 is equal to 0. So this basically tells me that if you evaluate a polynomial at some number, that number turns out to be the remainder if you were to divide that polynomial by x minus a number. Okay, so in other words, in general, let's say I have a polynomial p of x. In this case, it's x squared minus 4, and I evaluate that polynomial at k, and I get, in this case, I get 0. Okay, in the example that I have here. Well, that tells me that this is the remainder. If I were to divide the polynomial by x minus k, the remainder would be 0. Okay. So p of negative 2, as I pointed out, is also 0. So that means that if I were to divide the polynomial by x minus a minus 2, which is x plus 2, the remainder would also be 0. And of course, x plus 2 would be a factor. Okay? Now, consider the next one. Let's clear this. Consider the next example. If I were to take the polynomial, this x squared minus 4, and if I divide that by long division again, using long division, I would get an answer of x plus 1, and the remainder would be negative 3. Okay, the remainder is negative 3. And also note that if I evaluate the polynomial at 1, so now if I put a 1 where the x is, 1 squared is 1, minus 4 is negative 3, I also get a negative 3. Okay? So if you want to know the remainder, when you divide a polynomial by, say, x minus k, all you got to do is find p of k. Whatever number you get is going to be the remainder. Okay? So basically, this would tell me then also that if you evaluate a polynomial at some number k, we know this is the remainder. Okay, we just said that's the remainder. But if we get 0, then we also know that x minus k is a factor. Okay, so in the example that I have here, p of 2 is equal to 0. So that means that x minus 2 divides into this polynomial evenly, so x minus 2 is a factor. As I pointed out, p of negative 2 is also 0. So that tells me that x minus a minus 2, which is x plus 2, is also a factor. Okay, I'll point this out to you because in solving equations, as we saw in the first video, when you're solving a quadratic, one way to solve a quadratic is to factor it out. Okay, so if we can find the factors of that quadratic, which will be on the left side of the equation, one side will be 0, it's easy to solve it. Okay. I also want you to keep in mind that in this particular example here, p of x is equal to x squared minus 4. If I were to ask you, or somebody would ask you, what are the zeros of this polynomial? What are the zeros of this polynomial? Then you should know that the zeros are 2 and negative 2. Okay? Zeros just simply mean the numbers that produce 0 when you replace the x by that particular number. Okay? Now, notice a relationship here. If I were to ask you to solve something like x squared minus 4 equal to 0, this is very basic, but I suppose instead of an x squared, it would say an x to the 8th of higher order. Okay, it'd be more difficult, but just to keep it simple here, if I said solve x squared minus 4 is equal to 0, okay, so we want to find the value of x that makes this side 0 because the other side is 0. Well, it should be clear that those numbers are 2 and negative 2. So keep in mind the relationship between the zeros of a polynomial. The zeros of a polynomial p of x and how it relates to solving, say, p of x equal to 0. Okay. So let's go ahead and clear this. And now hopefully this will kind of guide you a little bit more clearly on the equations that we're going to do next. Okay. So here we want to find the real solutions. Remember, an equation can have real solutions or it can have imaginary solutions. As in particular, quadratic equations, we already saw that situation where you can have real solutions or non-real or imaginary solutions. So in this case, it says find the real solutions, if any, of each of the following equations. Okay. So I have the answers there again. Keep in mind that this is a third-degree equation. This is a third-degree equation. So I would expect to have at most 3 solutions. Okay. Just like if I just look at the polynomial x cubed minus 2x squared minus x plus 2, and I said, what are the zeros of that polynomial? Because it's third degree, you would expect to have at most 3 zeros. In other words, you could have all 3 being real zeros. It's possible that's one 0 is real and the other 2 are non-real. Just like in this case, we're looking at solutions. Okay. So the approach that we want to take here is we want to try to factor this. Okay, it's at x to the third, so the objective is to try to factor this. Because if we can have it in factored form, it's easy to set each factor equal to 0 and get the solutions. Okay. So what we're going to do is trial and error. We're going to try to find a value that works. Okay. So the polynomial on the left side is in descending powers, and the constant term is 2. So there's a theorem from College Algebra that tells you that if you have a polynomial and it has real zeros, the zeros are going to be numbers of the form p over q. In other words, they're going to be rational. Okay. Or I should say, I guess, if it has rational zeros, they're going to be of this format. If you don't have rational zeros, that's going to be a little bit harder to solve it, and you might have to use a graphing calculator. Okay. But if it has rational zeros, it has to be in the form p over q. Okay. And the rational zero theorem tells you that the p will be factors of the 2. Okay, so what are the factors of the 2? Plus or minus 1, plus or minus 2. Those are the factors or the divisors of 2. And the q, that is the denominator of that rational zero, if it has rational zeros, we factors of the lead term here, which is 1. So it's plus or minus 1. Okay? So that means you could have plus or minus 1 divided over plus or minus 1, plus or minus 2 divided by plus or minus 1. So this would tell me then that if this has any rational zeros, they're all going to be of the form, or it has to be one of these, plus or minus 1, or plus or minus 2. Those are the only rational zeros that you can have. Okay? So then what I would have to do then is test them out. Test them out. So I could plug in a 1 and where the x is. If it gives me 0, then I know that 1 is a 0, which in this case would also be a solution. Then I could try -1 and so forth. Okay. Now what I'm going to do is I'm going to use synthetic division. Okay. So in this case, what I would do is I would plug in a 1, a -1, a 2, a -2. Now since I already have the answers for you there, I'm just going to pick the right answer so that this won't take as long. Okay, but there's not that many choices. Okay, so I'm going to try 1 here. So synthetic division, remind you again that for synthetic division, you want the polynomial in descending powers, like this is, I have this one over here, descending powers. And then you line up the coefficients, 1, -2, -1, 2. There it is, 1, -2, -1, and 2. Now keep in mind that just like in the long division one that I did, if you have any missing terms, you have to put a 0 here. So let's suppose this minus 2x squared wasn't there. Say it went x cubed minus x, then you would have to, instead of a -2 here, you'd put a 0. Okay, so keep that in mind. This would be a 0. Okay, so synthetic division, it works this way. I bring the 1 here, okay? And then I go 1 times 1, and then I bring it to the next column there. And then I add these. -2 and 1 is -1. And then I multiply 1 times a -1 is a -1. -1 and -1 is -2. And then I continue 1 times a -2, take it over to the next column. So this will be -2. Okay, then I add these, get 0. Okay, so the last number in that last row is your remainder. So remember, this basically tells me then that when I evaluate the polynomial at 1, I get 0. So that's telling me that x minus 1 is a factor. Okay. And then what do I have? What do I have left here then? Okay, so basically this 1 represents a coefficient of x cubed, minus 2 the coefficient of x squared, minus 1 the coefficient of x, and then 2 is your constant. So because we divided by first degree, because that's what this is doing, when I put this 1 here, we're actually dividing it by x minus 1. So instead of an x squared now, this becomes an x. Okay, I'm sorry, instead of an x cubed, this becomes an x squared. Okay. So from here then, I can just say, okay, this actually factors into x squared. And then, so it goes in descending powers again. Instead of an x cubed, it reduces to x squared. So x squared minus x minus 2. Okay. So by just doing this synthetic division right here, okay, I factored this cubic polynomial into x minus 1, x squared minus x minus 2. And keep in mind, now I want to know, okay, does this quadratic right here, does that have any zeros? Which of course would be solutions to the equation, because this is equal to 0. Okay, but because it's a square, a quadratic, this one I can factor, and I get x minus 2. And x plus 1. So the polynomial then on that left side of the equation factors into x minus 1, x minus 2, x plus 1. So now once you have it factored out, okay, and it's a third degree, so we expect 3 solutions, okay, at most. So now it's just a matter of setting each of these factors equal to 0. So we've done this before in the other problem. So each of these is, you set it equal to 0, you get 3 equations, and we're going to get the answers that I have there. Okay, so this one, set it equal to 0, that's going to give me a 1. The x minus 2, set it equal to 0, that'll give me a 2. And the x plus 1, set it equal to 0, solve, and I get a negative 1. So those are the 3 solutions. I have it in a solution set there, but I'll just write it as x equal to 1, 2, and negative 1. Okay. Now keep in mind that if this coefficient of the x to the third had been let's say it had been a 3, then the factors of 3 or divisors would be plus or minus 1, plus or minus 3. So then your possible rational zeros that you would have would be the plus or minus 1, plus or minus 2 divided by plus or minus 1, and plus or minus 3. So you would have more choices than I have here. Here I only have those choices right there. But with this, plus or minus 1/3 would be a possibility. Plus or minus 2/3 would also be a possibility of a rational zero. So the only way you would find out is you would test it out, either by actually plugging it into the polynomial and the values for x, plug it in and see what you get, or you can do it using synthetic division. Okay. Now, if it turns out that you tried all these possibilities, 1, negative 1, 2, and negative 2, and you never got a 0 here in the last entry, then that means this thing would not have any rational zeros. They would all be, say, irrational zeros. In other words, it would have radicals. And it might turn out that you have one radical or one irrational zero, and then the other ones might be complex. Okay. Now let's clear this. And again, if I'm going too fast, please pause the video and rewind. Let's go to the next one. Okay. Now the next one, got x to the fourth plus 4x to the third minus 6x squared minus 7x minus 10 is equal to 0. Okay, so I want to find the real solutions to this, if any. So again, the coefficient, the last term here is a negative 10. So the factors of negative 10 are going to be plus or minus 1, plus or minus 2, plus or minus 10. Okay, and the fact that now it's easy when the coefficient of the lead term is 1, because all you're going to do is divide those by either a 1 or a minus 1. But that's going to give you the same thing, okay? So that means that the only possibilities that I have here for zeros are either a 1, a negative 1, a 2, or a negative 2, a 10, or a negative 10. And I guess I left that to 5, and plus or minus 5 here. Okay, so those are the only possible rational zeros that you can have, if you have any, okay? So again, using synthetic division here, I would put a little box right here, and I would just test these out, okay? So bring this one over here, and then see, I'll do the first one. I'll put a 1 here, okay? So 1 times 1 is 1. Add here, we get 5. 1 times 5 is 5. Add, we get negative 1. 1 times negative 1 is negative 1. Negative 7 and negative 1 is 8. Negative 8. 1 times negative 8 is a negative 8. And negative 10 and negative 8 is negative 18. Well, I didn't get a 0, so that would tell me that that would tell me that 1 is not a 0 of this polynomial, which of course means it's not a 0 of the, or it's not a solution of the equation. Okay, so I would try -1, and again I would get something other than 0 over here. What you're aiming for is to get 0, because that's going to give you a solution. At the same time, will give you a factor. Okay, so then I would go to the next one. Go to this, and I would try then a 2. Oops. So the 1 comes below this line right here. Okay, so I'm using the synthetic division. Okay, instead of the long division. So I go 2 times 1 is 2. Then we add here. 4 and 2 is 6. 2 times 6 is 12. Add, and I get 6. 2 times 6 is 12. -7 and 12 is 5. And then 2 times 5 is 10. Okay. So -10 and 10 is 0. So I know then that 2 is a 0 of the polynomial on the left side, which means it's a solution to the equation. Okay. And also I know that because I got 0 there for the remainder, x minus 2 is a factor. Okay. So if I wanted to rewrite this, I would write x minus 2, and then instead of an x to the fourth, this would be x to the third. So it would be x to the third plus 6, x squared plus 6x plus 5. But this is a cubic. Okay. So I want to continue. Okay. The objective is to try to get it down to a second degree, because we know how to handle second degrees. Okay, that was the first video, quadratic equations and so forth. Okay, so what I would do here again, keep in mind that you could have repeated roots. Okay, so if you get one that works, you would try it again. You could try the 2 again. Okay, it might work again. In this case, it doesn't, so I'm not going to waste the time. So then I would try 5. Okay, I would try 5, and 5 is not going to work. I'm not going to get a 0, just to save some time. And then I say, okay, I'm going to try -5. Those are the possibilities. Okay, so then I go 1 down here. -5 times 1 is -5. Okay, then 6 and -5 is +1. -5 times 1 is -5. 6 and -5 is 1. And then -5 times 1 is -5. 5 and -5 is 0. Okay, so -5 is a 0 with a polynomial, which means it's a solution. Okay, so I know then that just from what I've done so far, obviously here I'm looking for the solution. Sometimes you could have a problem like this and you would go through the same process because it might be asking you for the factors. Okay, but in this case, based on what I have so far, I know for sure that 2 is a solution to the equation because it's a 0 of that polynomial on the left side, and the same thing for -5. Okay. Now keep in mind now that this 1, 1, 1 over here at the bottom, we see we divided the x to the fourth polynomial by a first degree. It reduced to an x cubed, and then here, when I put this -5 here, that's divided again by a first degree binomial. So that reduces this. This actually becomes 1x squared plus 1x, or just x, plus 1. Okay, so now it's just a matter of factoring this out. So if this turns out to factor out, I might have 2 more real solutions. Okay, so what we want to do is, okay, let's test it out. You can see that the only factors of 1, so here we go, x squared is factors into x and x. And because it's a plus 1 for the third term, both signs have to be what the middle term is. That's a plus. The only factors of 1 are 1 and 1. So if I were to multiply this out, I'm not going to get this. I'm going to get x squared plus 2x plus 1. Okay. So this isn't factor. So now we say, okay, does it have a real solution? Well, if you look at the quadratic formula, which is, remember, minus b plus or minus the square root of b squared. We went over this in the first video in this series. Okay, times a. So all I'm going to do is look at what's under the radical, because remember, this is asking for the real solutions only. So if this number here under the radical is negative, that's going to be a complex or imaginary solution. So b is 1, so that's going to be 1 squared minus 4, a is 1, c is 1. So this is going to be 1 minus, and that's going to be minus 4, so it's going to be 1 minus 4 is negative 3. So it comes out to the square root of a negative 3, which is not a real number. Okay, so this does not have any solutions that pertain to this particular equation. So in this case, this would be it. Now, had this asked just for the solution, or if it just said solve the equation, and it didn't specify what type of solutions, then you would give these two solutions, 2 and negative 5, and then you'd have to figure out the imaginary solutions like we did in the first video. Okay? So let me clear this. Again, anytime, remember, just pause the video. You want to look more at the detail of what I did, just pause the video, rewind. Any questions, post them. Okay. Now let's go to the next one. Solve x to the 6 plus 6x squared plus 3x squared plus 11 equal to 0. Okay, now I put the answer there, and some of these I mean to leave them out when I do the presentation, but I forget. Okay, so I wanted for you to think about it. Okay, so anyway, you know the answer is no real solution. So how do we know it has no real solution? Without doing any calculation, just by looking at this equation, x to the 6 plus 6x to the 4th plus 3x squared plus 11 equal to 0. How do we know it has no real solution? Think about it for about 10 seconds. Okay. One way we would know is by using Descartes' rule of signs. Okay. I won't go over the details of it, but that theorem kind of tells you to expect whether to expect how many negative solutions to expect, how many positive solutions to expect, and so forth. Always keep in mind that only real solutions have a sign associated with them. Okay. So I can talk about, say, negative 2 is a solution, or if a 5 is a solution, this one is negative and this one's positive. Okay. But if you have imaginary solutions like, say, 2 plus I, or negative 2 minus 3I, those are complex or imaginary solutions. So we don't associate one as being a positive and one as being a negative. Negative and positive only applies to real solutions. Okay? So let's look at this. Notice I have the power on the exponent, and this one is even 6. The power on this one is even, it's 4. The power on this one is even, it's 2. So if 0 is a solution, you would plug in 0, and what I would get, 11 on this side, right? Because all of these would cancel out. I get 11 is equal to 0. So I know that 0 is not a solution. Okay. So the only question is, do I have a possible positive or negative solution? Okay. Well, notice if I were to plug in then a positive number for x or a negative number for x, because of the even powers on the x, this part right here is never going to be negative. Okay, it's never going to be negative. You put in a positive number because of the even power, it stays positive. You put in a negative number for x because of the even power, that's still going to stay positive. And then you're adding 11 to that on top of that. So there's no way that this left side is going to equal to 0. Okay. So I hope that is clear enough for you to realize that this one has no real solution. Okay. I'm going to clear this. And also remind you that I'm going to continue with videos coming up. The next video we'll look at logarithmic equations. We'll look at exponential equations. And so again, I'll continue posting a link to my other channel, the Dr. T Math and More, in case you want to look at what I have over there. I do have some stuff on technology over there, not just math. I do have a lot of math tutorials, but I also have some stuff on technology. So again, I hope I was clear in some of these. Feel free to post or suggest videos that you want to see, tutorials. And as long as you subscribe, I'd be happy to entertain your suggestions. So take care, and we'll see you in the next video.